Hello everyone, I am Li Xinyuan, a lecturer from Huawei. In the last lecture, we introduced Wi-Fi 6 and related products. In this lecture, we will introduce Huawei's VRP and how to upgrade our devices. This lecture is divided into two parts. One part is about Huawei's versatile routing platform, VRP. The other part is about how we can upgrade ACs and APs. VRP is a universal operating platform for Huawei's data communication products, centered on IP. It allows for various functions to be tailored and expanded. Mastering VRP is essential for using and configuring Huawei devices. Let's continue to look further. After completing this lesson, we will first know what VRP is as a concept, what kind of platform it is, its features, and we can understand the most basic ways to use VRP. Then the second part, we will talk about how to upgrade AC and AP, and how to distinguish between thin AP, fit AP, and fat AP. Finally, I will also explain how to configure services using a fat AP. Now let's move to the first section. First, let's introduce what the VRP system is. In this diagram, we can see our VRP is a large platform, and in this platform, we have many related bubbles: routing, switching, security, wireless. What does this mean? This means that under this VRP platform, devices like routers, security, wireless, and switches can all utilize this platform. At the very beginning, only some low-end devices used this VRP platform. But now, as technology has developed, most of Huawei's devices use this VRP as the operating system platform. Now let's take a look at the evolution of VRP. Our latest VRP is VRP 8. It started with VRP 1. In the first generation of VRP, we adopted a centralized design. Then it was only suitable for medium to low-end devices with relatively low performance. Of course, this was a long time ago, about 20 years ago. Then, in the second generation of VRP, we adopted a distributed design. After adopting a distributed design, function, extension, and feature tailoring became more flexible. This was also about 20 years ago. Then, later in the third generation of VRP, still a distributed platform, but with many more features. Here we started supporting core routers. Now we most commonly use VRP 8 and VRP 5 on both VRP 5 and VRP 8. There's a modular design, and we can apply it across multiple products, like ACs, APs, routers, and switches. It can provide very high performance. Now our products that we are using. You may encounter VRP 5 and VRP 8, these two platforms we will come across. Then some of the latest products, usually we use this VRP 8 as our platform system. So we just talked about what this VRP platform is. It is a universal routing platform. Now this might sound complex and seems like a very advanced thing, but in fact, this VRP is just an operating system. We commonly use PCs. Students are definitely familiar with many different operating systems like Apple's macOS and the Android on our phones, as well as our Windows and Linux. Some students may have also used Unix. These are all operating systems. Our VRP is also an operating system. What is an operating system for? It's to effectively manage our hardware and use our hardware to implement our functionalities. That's the purpose of using an operating system. So, in an operating system, what might be the first thing we encounter? It's the file system. Why is that? Because if we want to use an operating system, first of all, we need a file. This file contains the operating system code. Then we use the device to run this code so that our device can start up. Therefore, the file system is the most fundamental and a core part of our operating system. Let's take a look now. What does the VRP file system look like? Our VRP file system is divided into four parts: system software configuration files, fixed files, and PAF files. Let's take a look at them one by one. First, the system software. This so-called system software is what we use when booting a router or a switch. Simply put, booting a router or switch, or as we're discussing this time, an AC or an AP, you need to boot up this system. A software is essential. At the very least, a basic software. The file extension for this software is .cc. Only with this software can our equipment start up. Then we can log into the device, either through the CLI interface, or configure the device from the web interface. This part is the system software, which is very, very important. It's the foundation for the operation of our equipment. Once we have the system software, what do we need to do? Our equipment has already started up. We need to configure. Here we utilize configuration files. When setting up the device, we can input various commands, and then these commands can also be finally saved. Even if we wish, we can save multiple configuration files for use in different engineering environments. We can use different configuration files. That's what configuration files are. The third is patch files. We know our devices are made up of code that people write. And as long as it's human-written code, there will inevitably be various issues. No problem. We can correct these issues with patch files, or fix some bugs, or perform various large or small upgrades on our devices. That's where we need patch files. The file extension for patch files is .pat, which stands for patch, meaning patch. P-A-T-C-H, patch. So the last one is a PAF file. This file, you may not be as familiar with it, this file is used to tailor our product resources and functional features. It's used for customization. The file extension here is .bin. This is our file system. File systems are very important. Windows often uses FAT32 or NTFS. These are commonly encountered when using a Windows PC. But our file system is different from others. This is our VRP platform. You could say it's this operating system's unique file system. And within this, the fourth type of file, everyone should be aware. Now that we have the files, if we want to start this device, then we need to read the files. If you want to read files, your files need to be stored somewhere, including after your device starts up. During operation, we also need to constantly store or read files. So, the storage and retrieval of these files require us to use many different storage devices. There are volatile ones, where data disappears when power is lost. And there are non-volatile ones, where data remains. Let's look at them one by one. First, let's consider flash, which we often encounter in maintenance. It's probably the most frequently interacted with, especially in our human-machine interfaces. Why is that? Because we know we need to configure our devices. After configuring, where does our configuration reside? Your first choice is generally flash, which is a type of non-volatile memory. That is, similar to the SD card in our phones, power off, but the data doesn't disappear, so we can store our configurations in it. If we also need to upgrade the device, or make some functional customizations, we need to use patch files and PAF files. We can also upload this file to flash. Once uploaded, it can be executed. Everyone should know that flash is the most commonly used. So, after power is lost, the data in flash will not disappear. In relation to flash, there is also an SD card. This SD card is similar to the ones used in our mobile phones or digital cameras. It's similar also a storage device, where data also doesn't disappear after power loss. So, students might ask, if we already have flash, why do we still need an SD card? That's because if we want our device to be more secure, then we can use an additional storage card. Place it onto our main control board or another location. This way, we can also duplicate our data onto an SD card. By doing so, we can significantly enhance our security. Our system files, configuration files, logs can all be stored on the SD card. These are our two non-volatile storage devices where data does not disappear after power loss. These are also the two storage devices we most commonly encounter in maintenance: flash and SD card. However, the SD card is removable, similar to an external device, while flash is usually embedded in our device on the single board. It cannot be casually removed. Next, let's look at another SD prefixed, SDRAM. Then let's take a look at another SD-headed term, SDRAM. This SDRAM, if you know a little about computers or know a bit about our PCs, will be easy to understand. This is what we call RAM, our programs run, needing to read from flash or the SD card and load it into RAM then to the memory so that our device can operate normally. This is what memory is. And what is NVRAM? It's non-volatile random access memory. This is also our storage, but it's different from RAM. It's used for storing our log cache files. only when the TV times out or the cache is full. We only write logs to flash when this storage is usually in use. We might not notice it, we might not pay attention to it, but this SDRAM actually, we can see it. When we check the status of our devices, we can see how much memory is being used, what percentage it is occupied, and whether the device is under heavy load. We can look at the SDRAM usage to understand the state of our device. The last one is USB. The functionality of this USB is somewhat similar to that of the SD card. If we have large files, such as a large upgrade package, that need to be used to upgrade our device, then our device can also be connected to a USB. That is also possible. So these are the storage devices we encounter in use. The one we use most commonly is still the flash. Our configuration files and our software patches can be stored on flash. Then they can be run. So these are our storage devices. Now our hardware is ready. And then our data is also ready. Now we power up and we can start up our device. So upon starting up, what's the first thing? Boot ROM. This boot ROM is similar to the BIOS on our PCs. BIOS is the basic input-output system. This system is also embedded in what can be described as a chip. Through this boot ROM, we can guide our device, and then allow our software to start up normally. Let's take a look. After starting up, first, there's a BIOS. You see, this here is the basic input-output system. The basic input-output system. This is our BIOS. The time this file was created, the creation time. Then here's the memory check, it's okay. And after a series of processes, finally this step, you see this red text, now boot from flash. This means we can now load our operating system. Until now, the operating system was not loaded. Until now, it was just the boot process, the device self-check procedures. From this red text on, we will load our system. Our system, AC6508. This is our device model. And next is the software version, V20022019C00 SPC500. Following that is DAIC. DAICC is our operating system. You all remember, right? Earlier, we mentioned the file extension for the operating system is DAIC. After this process, our device can start up.